Okay, first things first. We've made a couple of little changes from the previous project. Our API now has a default action, which involves setting up the routing. So you'll need to Google to see how that works, if you don't already know. Now we have getProduct with no parameter, returns all the products as a list. GetProduct with the parameter of an ID gets the first or default matching the ID. Now we have two new methods. These ones are the ones that we're going to write the test cases for. We have one called GetBargains, in which we return all of the products that are in stock and have a price of under $1,000. So one of the things we did when we were off the air was add a in-stock property to the database table. And now we return with the second one, get expensive, which is get the expensive items, all items over $1,000, whether they're in stock or not. And then the add product to DB that we already had. So now that that's changed just a tiny little bit, what we do is regenerate the NSWAG studio portion of things and regenerate the client, and everything works fine from there on in. You can use the Swagger interface and check all of those things, that all works. So the other thing that we've done now is opened up our client program, and I've made a new class that does nothing fancy. The new class is called a products checker. Inside we have an internal class variable called products. When we instantiate the object and we call this method, are they all in stock? We pass in a list of products. We check to see if the product list is 0 elements long. If it is 0 elements long, then they're clearly not in stock. If any one item of the products that were passed in is not in stock, or in stock equals false, then we return false because they're not all in stock. If neither of those two conditions are true, then we return true because either the one or more items that are in the list, all of which are in stock. So this simple little method does nothing other than tell us whether the items in the list that was passed in are all in stock or not. So for argument's sake, we've added a few lines to our console client. We get every product and save it into a product all list. We iterate through all the lists, dump them out to the console, pass them in to check, are they all in stock? Not all items are in stock, so of course that fails. Then we do the same thing again with the list of items over $1,000. This time we do it using the Lambda expressions on top of the product all list rather than getting them from the server, so we use the local copy. We check to see if they are all in stock. Then we do that a second time, and this time instead of checking the local all products list, we get them from the server over the API. Do the same thing, check that they're all in stock. So these two lists will return the same values if the code is correct. And then the third one is return all the values, all the products that are under $1,000 via the API. So if we run that quickly, what we'll see is the four lists. 1, 2, 3, 4. Are they all in stock? Yes, yes, yes. And the all items list, not all of those items are in stock. So now, the purpose of the unit testing is that if the code inside this method were to change, the functionality that we desire from a method that says, are they all in stock, is pretty clear. If we were to find a much more efficient way of doing this, or we were to refactor it, or we wanted a new naming convention, or something else fundamental changed, but the overall functionality of the method didn't change, we could refactor this code internally, and then run the unit test on it again. So what we're going to do is write a unit test to validate this are they all in stock method. So we have the three cases, no products in the list. There is a list, one or more of them is not in stock, therefore the whole list is considered not a list of items that are all in stock. Neither of those are correct, then the list is items that are all in stock. So we have three exit cases, or three code paths. So what we need to do in our unit testing is test those three code paths, or at least those three possible outcomes for that method. the simple starting place is we have unit testing project in our solution. That was created when we first created the project in the first video. So we open up the unit test CS, and in this case we're going to say, we probably want some kind of useful naming convention. So let's rename test class to products checker tests. Okay, so these will be the tests that are purely for the products checker. So the first test method, I think we want to say, what did we call that? It's called, are they all in stock? So using the naming convention that Ashley Dawson put forward in the SharePoint documentation and the wiki, let's rename our method, are they all in stock? Scenario and expected behavior. So this way we can easily determine which test methods test which things. So I think the first one that we'd like to test is obviously the first code path. So there are no products in the list. So scenario, no products in list. The expected behavior is based on what we see here. There are no products in the list, the count is 0, we return false. So the expected behavior is returns false. Okay, so we now have a single test method that is going to test that function. Now we want to keep going because we have no products in list, we've already checked for. So now we have product in list, one of them is not in stock. Products in list, one or more not in stock. So this too will return false. And we need a third one. Are they all in stock? And we have products in list, all are in stock. And this one is going to return true. So these are going to be our 3 test methods for that class and its one method. Now moving on, we're going to follow the fairly standard methodology of arrange, act, and assert, where we arrange our variables and our code to set up the scenario we wish to test. We're going to act out the scenario and then we're going to check the results. In this case we want to make a product checker class and we need a list that we're going to check. So we're going to hard code these because we don't want to go to the database for this like an integration test. We're just testing the functionality of that method, not the underlying functionality of the classes that use the client and connect to the database. We just want to make sure that that product checker, are they all in stock method works correctly, not the underlying technologies that are further outside of this scope. So to begin with, we're going to need a products checker, and we're going to need a products list. So we're going to make both of those. I'll cut the video while I type those in, and I'll pre-populate the list with some default values with the constructor. Okay, here we have a product checker instantiated, and we have a product list. So in this case, we're going to steal this particular reusable piece of code and put it somewhere else because we actually want to test the first time around with an empty list. So we'll throw that in the second test method. We'll comment this out because we want an empty list. So now we have a list with nothing in it and a product checker. That's going to be our arrange section. So this should return false. We can delete those because we're never going to use those in this method. Now what we're going to do is write the other two test methods. So we're just going to reuse a little bit of the code. We're going to reuse the product checker. When this time we have a products list. We have a cheap item that is in stock, $100 in stock true. We have a cheap item, $300 not in stock, an expensive but in stock item, and an expensive not in stock. So this will be our second test case. One or more items are not in stock. We expect this to return false. So let's copy this code again and put it into our third test method. This time round, we have products in the list and they are all in stock. So let us change the constructor and allocation of the in-stock status for our in-memory test. So now we have our arranged portion of the test methods. Now we're going to have to actually perform the test and check for each of the three. Okay, so the first thing we want to do in our act is we want to store the result that we're going to check. Let's say var result equals, so we're going to use our product checker, and we're going to say, are they all in stock? And we're going to pass in our products list, our reusable products list. Okay, so when we call this method, we're going to store the result of the product checker on this list, and the list happens to be empty in our case. And then we're going to check the results. So we're going to, again, copy this particular line of code and reuse it in all three tests. So the only thing that's going to be different about the assert section is going to be the result that we assert, so it's going to be true or false in the relevant cases. So let's write that. So let's write that assert. Let's go assert is false. Assert is false result. Okay, so this test method is going to return false as well if everything works correctly. So let's go to our third one. Assert, wow, I really am not very good at spelling, is true result. Okay, so they are the three test methods to test our class and its method in here. So we're going to now be able to check our are they all in stock. Okay, let's try our testing out. So we go test, Windows, Test Explorer, and we have three tests for the product checker. Are they all in stock? Let's expand this a little bit. No products in list returns false. Are they all in stock? Returns true, products in the list. So let's run these. Run selected tests. Products client does not contain a definition for get all products async. Oh no. Let's have a look and see where this error occurs. This is inside my WPF application that we don't really care about right now. Sorry about that. Let's save that. Let's rebuild everything. It would be something that's completely unrelated to what we're testing, wouldn't it? Okay, let's try this again. Select these, run selected tests. Run test started, test finished, 3 run, all our tests passed. Excellent. So now, the important thing about this is we have these tests and we have a program. Now, if we wanted to change some of the functionality of our program and then retest it in order to verify that the methods we're using don't change in their fundamental behavior, even if the code inside them changes, we can redo that. So in this case, let's refactor this. If any product is not in stock, then they aren't all in stock. So for each product, let's say if it is not equal to false. So this is obviously faulty logic, so when we rerun the test, one of these should fail. So there we go. API tests under the product checker, one of which failed. So in this case, we were trying to refactor this code. So we were trying to say if in stock equals false. So let's change this to look slightly different. Let's say if not in stock. So if product is not true, so product in stock is not equal to true. So we just change the Boolean logic there. Now we've saved that. We want to recompile our console project. Not sure if we have to compile it actually for this test, but succeeded. Let's rerun the test. Okay, that works. So this gives us a method to change the logic inside our program while not changing the interface between methods and functions, and allows us to refactor code, make things more efficient, make things multi-threaded, make those changes that we want to make every day, and then run automated tests in order to verify that the basic functionality, the individual units of our code perform as we expect them to.